5G is promising to be a really revolutionary technology based on the promise of what it can do, how it can do. So there's a lot of interest. There's a lot of interest around 5G, and I like Ben's presentation on some of the use cases. I didn't think much about 5G in agriculture, but looks like there's a solid use case out there. So really, really interesting. So I'll first want my panelists to just introduce themselves, and then we get down to the business of the panel. So starting with you, Gershon.
Good afternoon. My name's Gershon Gitonga, in charge of planning, network planning and design at Safaricom. So this is mainly radio, core, transport, and anything that relates to the network. Been in the field for quite some time, close to 20 years, and it's been a very exciting journey. Looking forward for an engaging session. Thank you.
See, Gershon is such an engineer. He talks about transport. It's not Matriz. No, it's not. But he'll explain further. Ben?
Hi, everybody. Yes, I'm Ben Roberts. I am Chief of Technology and Innovation at Liquid Intelligent Technologies, looking after all of Africa and the things that we're doing in the new technology developments.
Adam?
And good afternoon. My name is Adam Lane. I work in external affairs, external relations, including working with ecosystem partners, government, NGOs, international organizations at Huawei in Kenya. I think many of you will know Huawei. We do the B2B networks for telecoms providers, as well as for enterprise, government, other users, as well as having consumer division, cloud, and then now a digital power division as well. Thank you.
Thank you, Adam. Maybe we start with you, Adam, because I think you guys have built a lot of the existing 5G networks in the continent. Is that correct?
Yes.
So what's the uptake of 5G across the continent?
So there's now, as Ben said, there's several countries now across Africa that's launched 5G networks. There's only a couple that are really that commercial, I suppose. So Africa's certainly the furthest ahead. I think at least 3, if not 4 of the operators there have launched 5G services. Kenya is catching up, and Nigeria is now also launching 5G networks, and others are really in very, very early stages. I mean, the main purpose of 5G, and I think we'll be like that for several years in Africa, is not to connect your smartphone. In a sense, not even to connect your enterprise, just to connect your home. I think in Kenya, as less than 1 million homes have internet through fiber or through other fixed means, and Ben mentioned this idea of fixed wireless access, which is such an oxymoron. They can be fixed and wireless, but by basically think of it as getting the level of service you get from fixed networks and the thinking around pricing of a fixed network, based on speed, not based on GBs per se, but you're getting it through a wireless technology. And that's critical. There's, 10, 12, 15 million homes probably in Kenya, and if only less than 1 million have got any kind of fixed network, that's a huge number that don't. And they're not going to get that through fiber in the next short term, to be honest. The cost of stringing fiber is quite expensive. The distances it needs to go, it's not that easy. When you have a mobile network, you upgrade one base station for 5G, and anyone within, 5 kilometers roughly, depending on what frequency spectrum you're using, can access that 5G network and get a fiber-like experience of speeds. And I think if you look at Safaricom's website, I think their fiber prices actually are very similar to their 5G prices, almost identical actually. I think maybe you have to obviously buy the router, the 5G network, but I think that also comes for free with a 2 or 3 year plan or something. So that's that's the biggest use case of 5G. It's about connecting your home if you're in an area that hasn't got fiber connectivity through this CPE, as Ben called it, customer premise equipment. It looks just like a Wi-Fi router, but instead of plugging a fiber or Ethernet cable in the back, it's running off a SIM card. It's also like a dongle or a Wi-Fi, just normally plugged into the mains power. And most interestingly, the best CPEs out there are outdoor CPEs. So they go on the outside of the building, then they often connect through a Ethernet cable or fiber or another copper cable inside the building where you have your actual Wi-Fi router. just by having the antenna on the outside, you get a better signal, better coverage, better speeds as well. But it's not necessary. You can use just indoor ones as well.
Ben, do you have any information on the uptake of 5G across the continent?
Yeah, well, I think this is working.
Yeah.
It is. Yeah, yeah. So it's the uptake on the subscription side is still becoming slow. But I do think that the important use case is going to be this fixed connection. And we're seeing that will grow. There's going to be there's about 8 million homes that could have internet in Kenya, and there's very few. It's less than 1 million that have some kind of connection. What's going to be quite challenging? I think there's a lot of obviously we have the known players that people have for their home connections. You have the Zukus, the JTLs, and Safaricom. But there's an awful lot of people who are, my local guy, that guy who puts internet in my locality, and I don't think that itself is a challenge to a number of these emerging technologies, because what the local guy does, generally they take one connection from one of the providers, could be wireless, or it could be 5G, it could be Starlink when Starlink launches in Kenya. But they then share that around, and then they degrade the experience. So they make it a lot cheaper, but that also is going to be. We're going to see the same thing happening with the 5G connections. If the packages change so that you're given unlimited data and you're given this is the speed and your unlimited data, we're going to see that local guy taking one, and you're expecting to get 1,000. Customers in that area, you'll find there's 2, and there's 2 local guys, and they're sharing it with that whole locality. So that's still going to affect uptake of all of these things. So, and the main, the smartphone, the expensive smartphones that people are using with 5G on, I'm not sure that it's necessarily impacting people that much. My wife has 5G. I've actually got an iPhone 11 that doesn't have 5G. It's a better phone than me. I said to her this morning, preparing for this, you had a 5G phone for 2 years. What does that mean for you? She said nothing. It just says 5G on the top. So, so it's going to make a difference to people who want a fast broadband connection at home.
Okay. Gershon, you guys are deploying now. So just the same question, but then maybe you can go further and tell us what are some of the challenges you're seeing as you deploying, or what are the why is there slow? Because you see, the expectation was that when 5G is launched, for instance, in Kenya, then there'll be like a groundswell of people coming to Safaricom to get 5G, or what are you seeing on from that end?
Thanks. Okay, for deployment of 5G, number one that we are seeing is what Ben has just said, devices. We have very few people who have 5G devices. In an ecosystem of around 38 million customers, you find 5G-enabled phones that are currently within the ecosystem. Less than 300,000. That's like 1%.
Wow.
Yeah, or less. So devices is one of the key factors that is making the uptake.
So it's a factor and an opportunity.
Yes.
Okay.
Yes. So let's also remember, when 5G is there, it will coexist with the existing technology, because currently we have still 2G, 3G, 4G, 5G. In our market, we'll still continue having them for quite some time, but we are projecting one of them will go some years to come, especially 3G, but the rest will still remain. So one of the challenges is the devices. The second thing that is there is 5G is much more expensive than all the other technologies. Actually, it's around 60% more expensive than 4G in terms of deployment. But in terms of efficiency, it is the most efficient because you carry much more data with one equipment. So those are some of the big challenges. So if the devices increase, you have a big ecosystem, gives us more incentives to invest more, because right now you find these only pockets of people that are having the 5G device. So what we've gone ahead is, as my panelists have said, is going into other areas like fixed wireless access. Where you can't get fiber, we give you a fiber-like experience using 5G. And we have also gone ahead to involve the government, and last year we simulated virtual tourism with 5G, whereby we deployed a 5G site at Savo, and you have 5G at home on your phone, but you are a tourist. You are assume you're in Savo. Then we put a drone, go where the elephants are drinking water. Then you become a tourist virtually, and it works magic because it gives the impression that you are at the park. So that is one of the use cases, because if we look at the use cases that are there in the world.
So virtual reality, mixed reality.
Exactly.
Okay.
Yes. If you look at the cases that are in the world, other places, autonomous cars and remote surgery, they are not here with us in Kenya. So we are trying to make use cases for us that will be more useful in Kenya using 5G here as we develop our market.
Okay.
Harry, can I add something quickly?
Yeah.
Just on the device issue, I think the biggest challenge is not the cost of the device per se. The device is now with 5G, I think around 25K in Kenya. The issue is the slow upgrade that the majority of people take to upgrade their phone. Whether it's 3 years, 4 years, sometimes 5 or even 6 years. So that's really the issue. I don't blame. Obviously, costs can come lower, of course. Eventually, the 5G phones will be like 6, 7, 8, 10K. But the issue is it's just most people keep their phones until they break. And if they can last 4 or 5 years, then wonderful, you can do that. So that's the biggest challenge. In the richer world, people mostly get phones on contract. Every 2 years, sometimes every 3 is automatically upgraded. And then, of course, you're going to get the 5G phone when it's been upgraded automatically, in a sense. But most people here are not doing that. So that's probably, I think, the biggest challenge. And there's nothing wrong with that per se, but that's certainly the challenge. Yeah, I think maybe in the future there'll be more people using MiFis and things for 5G if they really needed to. But 5G is not for the consumer, right? It doesn't have that many benefits for you as an individual smartphone holder. Because 4G, especially 4G Advanced, 4G Plus, as Falcon calls it, is very, very good. You don't really need 5G if you just have a small single smartphone. If you start having 8K TV or whatever, maybe you start needing something bigger. But just a single smartphone, you don't really need it for. You don't really need 5G for it, to be honest.
Can you give like a very understandable difference between 4G and 5G?
One is that I touched on the latency, right? So, we see it. I've seen this already with a number of our customers. People who have an office in Nairobi, they've got branches all over Kenya, and they've got workers and users who are accessing some kind of an ERP system that is hosted either in the cloud or back in the office in Nairobi. We're currently using we have fiber, but we also have a wireless network. We're using 4G technology on that, and sometimes some of those customers, when they connect that branch or they turn on that application, they'll start screaming, right? Because it might be 50 milliseconds. That might only be in a branch in Bomet, but it could be 50 milliseconds latency to connect from that office back to the Nairobi HQ. And we've generally been upgrading those people to sort of fixed microwave network links. So because we're doing dedicated services, we give them fixed microwave links currently, but that's going to be an application for 5G as well, right? Because this 5G is going to sustain like the fixed microwave. It will bring that 40 millisecond latency down to about 1 millisecond. So it will be just the same as a branch if it was somewhere else in Nairobi. So that is making a difference to IT people. It's not every application that's sensitive. Certainly the main cloud-based applications like your email and things, they've advanced a lot in the last few years, so they're less latency sensitive, but certainly ERPs and things, they can.
You wanted to say something?
Yeah, I wanted to add on that. 1 millisecond is the delay for 5G compared to 4G, which is around 10 milliseconds. If you go to 3G, it's around 37 milliseconds. So one of the biggest applications is that. The other one is the speed. So 5G, what is giving us, it's giving us fiber-like experience, but with mobility. So the key thing with 5G is mobility. You're able to do what you are supposed to do at home, but on the road, on the go. Yeah.
So we can now start talking about business mobility for real.
Exactly.
Okay. So this is mostly to Adam and Ben. which technology is 5G going to disrupt?
Good question. I suppose to some extent, it's, if you look at the enterprise use cases, it's sort of a disruption of Wi-Fi. So if I look at in South Africa, we've been doing an industrial use case on a 5G-enabled mine with MTN and the mining company and obviously the equipment providers. And to be honest, you could sort of provide this solution using Wi-Fi off fiber, but Wi-Fi has many challenges compared to 5G actually. 5G actually has better quality of service, better handover between devices in the sense, and other benefits around that as well. And also actually in many cases better latency too. And of course the mobility factor, Wi-Fi, the distance or the range could be 50 meters. It depends obviously on walls and things, because Wi-Fi could be, 5G could be 5 kilometers or whatever. So I think, if anything, it would be that. But of course, if you had some incredible fiber and you had every single access point on fiber, not on Ethernet cable, for example, ultimately Wi-Fi could kind of rival with 5G at some point, but most people don't have Wi-Fi off fiber, they have Wi-Fi off Ethernet, they don't have that many access points and that many advanced things. So I would say to some extent it'd be that, but in reality, it's not displacing, it's a new thing, it's a new concept. That's why I think it's been slow to take off. So when you look at this 5G mine in South Africa, it requires a pretty big investment, not in the network piece. You have got the machinery, but now they're remote controlling. So you have to put the CPU on the machine, and the machine itself has to be capable of doing remote control. So that may need some upgrades to the hardware or the software of the mining machinery. The CCTV cameras, because a lot of it is for CCTV and surveillance to know what's happening in the mine from safety and other things. Some of that could be mobile, right? Camera on the body camera or on the helmet. Or it could be on a fixed site. So if you don't have 5G-enabled device cameras, you need to have a CPE linked to it through Ethernet or fiber, or you have to have a 5G native device. So that's kind of the challenge, that people have never bothered to make that investment before. And now they're realizing, actually, if you look at it from the health and safety benefits, the economic efficiency benefits, to some extent labor benefits, of course, it's a very difficult compensation to have in Africa where there's huge youth unemployment. Unlike in Europe and Asia and US, where there's actually a lack of workers, actually, and that's one of the issues driving inflation. There are reasons to invest it, but it does require investment. I think that's why it's been quite slow for enterprise user cases. And if the investment's only worth it if you get a real benefit. And for many people, they've not really invested the time in thinking through what is the real benefit. If there are many cases of benefits, I think the biggest benefit we've seen is probably around ports. In Asia, because ports need to be very, very efficient, and it's a brutally competitive environment and a very, very complex environment with lots of different equipments and machinery coming and going. So there's really good efficiency. That's a massive industry, right? These are $1 billion per day kind of revenue turnover entities. So in that case, you see a real business case for that. Sometimes with mining too, because minerals and things are worth lots of money. But for some of the other things like agriculture, it's not as obvious to make the investment in some of those use cases.
Ben?
I think two technologies I see probably being killed, actually, eventually. One is 3G, right? And you alluded to this. We will see 3G networks being turned off. And we'll see that public networks are going to retain 2G for compatibility with very old POS devices or very old phones that are just voice only. And 4G will remain, and 5G will be there on the networks. 3G will just go, and anybody who has a 3G only data phone will just have to buy a phone that has a data signal on something else. And actually, I see like Ethernet cable as being very disrupted. Cat5, Cat6 cable is going to be very disrupted, because you are going to, if you've got a personal device, doesn't matter what it is, whether it's a laptop, a phone, a VR headset, or something you carry on your person, you're going to access that either via a Wi-Fi network or via a public 5G network. And they're going to be the only two methods. You're never going to plug that in. I don't plug my laptop into Ethernet. I did it once because I was in the stores and there wasn't a very good signal where I was, and I wanted to use it in a part of our equipment stores. But I used to love plugging into the Ethernet. I don't do it anymore. So we're going to see then that Ethernet is going to be something you're going to use in the data center to connect your servers to the switch. But you're going to use fiber for that. You're going to use a fiber Ethernet. So we'll see the death of of Ethernet itself. Maybe only the use Ethernet is going to have is going to be for PoE, for powering a camera or something where you need a power signal going to either a Wi-Fi hotspot or a CCTV camera.
Okay, anybody selling cable here? it's time to pivot. Okay, okay, yeah, we can open up to the audience. State your name.
Sure.
And your interests.
And my interests, definitely not cable. But yeah, so thanks, Harry, and thanks to the panel. My name is Francis Mwangi from Platcorp Holdings. So there's, some time back there was a discussion on the risks surrounding 5G, and especially when it comes to health issues. There was some unverified information that possibly could lead to cancer or something like that. And then also disruption when it comes to possibly, when planes are landing at airports, the altimeter device that assists in communication with the control tower. Maybe you could touch on that and possibly get to tell us whether that's a concern anymore. And also, what are the security risks that we are looking at? Thank you.
We get another question. Yeah, Kanda.
Peter Kanda, once again from Gertrude's Notch-Chain. Quick one to Safaricom, Liquid. I both consume your services. This is on the enterprise level. And we offer telemedicine solutions in some of the remote sites in the country, and we have significant challenges in terms of latencies and that kind of disruption in terms of tech. Do you see low Earth orbit satellites converging with 5G? I'm talking about Starlink,
Interesting.
Kuiper, and them coming to disrupt the space. And will that happen within over the next 1 year? Thank you.
Good question. Good question. Okay.
Okay.
Oh, go ahead.
Yeah,
okay,
yeah,
you can check that.
Yeah, so good question on the Starlink one. I think I also had that one. And now that you're talking about 5G, could you also...
Did you introduce yourself?
Steve Gitahi, IoT, iLab Africa, Internet of Things Department.
Okay.
Yes. Closely related to this, probably this is the best panel to comment on it, the potential of Wi-Fi 6E for IoT adoption. Just very slightly, I know it's beyond 5G, but a quick comment on that.
Okay.
I'll take the first question.
All right.
The one with the planes, that was reported in the US. The only problem with that is the planes that were affected were using the same frequency range as the 5G signals that were installed at the airports. So they were supposed to have moved from that frequency range. In Kenya, we are using the 2600 megahertz range, which was freed for 5G. And all the operators that requested were given the specific bandwidth. Then the other question was about...
Health concerns?
About health, that has been studied all across the world. Many studies have been done, but there's nothing that has shown that the signals interfere with your body or give you any problems like cancer or the rest. So every time we deploy, we get clearance from NEMA and all the other authorities. And actually the power levels and everything is monitored. The second question, before I give my panelists to look at the third question, it's good business. Now I've picked some business here, so we'll meet after this.
Hey, boss, I need to get a commission out of this.
Yeah. So we don't see the orbit satellites because they are not able to achieve the latency that we can achieve with the 5G. Satellites have a much higher latency. So we will still be able to connect the terrestrial using fiber. 4G, 5G would be the best solution. The orbit satellites will not be the best. You'll get much more delays, as you know, satellites, even if they are low orbit, still have that inherent delay of the transmit and receive.
I'll elaborate more on the LEO. What we'll see Starlink has already launched in Nigeria, and there was also news that they are also connecting and peering at the Nigerian Internet Exchange Point. So Kenya is going to be, they won't have an a ground station in every country, but they will end up having necessity to have ground stations in Kenya. which will connect directly onto internet exchanges. So for your application, which is telemedicine, I think it will be, potentially could be useful in terms of being able to go into the very remote clinics with something. The drawbacks, it's going to be a very interesting product that's going to have a good use case. The pros and cons of the thing are that, with the current product and pricing, the terminal that is being sold pretty much is a similar sort of cost to an ordinary VSAT terminal we have for geostationary satellites. And I've sold a lot of geostationary satellites across East Africa, and particularly connecting schools. But the reason we don't have more is because of that $600 cost to get the dish. And if we didn't have a $600, if we give them a modem that was $50, I'd sell a lot more satellite links, right? It's very simple. And so it's going to be, the other thing is going to be the density. So everyone's saying, is this going to come and disrupt, the fiber in Nairobi? And no is the answer, just because that beam is going to cover a certain area, and there's only going to be so much capacity and frequency available on that beam. And once you have put enough customers on that beam to fill it, you aren't going to be able to get any more customers. So if you put a beam, an LEO beam over Kiambu, northern part of Nairobi, Kiambu, 30 square kilometer beam, you're only going to get about 400 customers on there. Now, the addressable market in the area is way, way, way more than 400, and you're going to have, you'll put a tower here and you get 300-400 customers. You're going to have to, but they can't do that because they can't get any more. Can't get any more beams to overlap it. That beam can't get any smaller. So they are going to have the Gen 2 satellites from Starlink, and they've made a strategic land grab to put some of those in space. But that's going to be, let's see if it even lasts that long, right? I mean, I'm yet to. If they don't prove their business model on the Gen 1, they're not going to launch tens of thousands of Gen 2s.
Okay. IoT.
Okay, so my understanding of Wi-Fi 6E is Wi-Fi 6, but like the E stands for different spectrum range that it's using. So Wi-Fi 6 generally uses 2.4 and 5 to 6 gigahertz range. Wi-Fi 6E is now starting to look at the 6 gigahertz range, from 5925 to 6425, which is what's being proposed for Africa. And the US has gone to extend it all the way up to 7125. The US has taken a very unusual approach by allocating the whole amount for Wi-Fi, which means it wouldn't be available for mobile use. They kind of messed up with 5G about 5 years ago with their spectrum bands for 5G. They used very, very high frequency millimeter wave and very, very low frequency, around, was it 600 megahertz, both of which are a bit of a disaster for 5G. The speeds on the 600 megahertz spectrum were actually sometimes slower than 4G, because maybe the 4G was 4G advanced, although it has very long coverage, and the millimeter wave 5G is pretty bad coverage. Literally a tree or one wall would block you from getting a signal. So it could be potentially fine to use that in a very specific environment, but for a nationwide network, it doesn't work, and you need something ridiculous number of sites to cover it. Then the US realized it kind of messed up, spent, I think it was $140 billion or something to refarm the spectrum away, the ones that actually touched upon the altimeter one, to use that for 5G, and now they're catching up with the rest of the world in a sense in building a proper network using a better band of spectrum. So whether they'll make the same mistake with Wi-Fi, I don't know. Many US companies are very, very, very pushing Wi-Fi 6E. People like Apple, Intel, Facebook, the Facebook or Meta people got a few laughs recently at an Africa-wide spectrum conference by saying if you don't allocate this entire band of spectrum for Wi-Fi 6E, Africa will miss out on the metaverse. And most people were kind of laughing, thinking most of us are barely on mobile internet. If you look at Africa as a whole, I'm not sure we need to be really worried right now about the metaverse. Not that it's a bad thing per se, but the guy just came in at this level that I think lost a little bit of respect amongst the rest of the audience. But anyway, so when it comes to your issue, if you look at, there's different channel size in Wi-Fi. So by having a bigger band of spectrum for Wi-Fi, you could do bigger channels and more of them, which could give you greater speeds. Currently, the Wi-Fi 6 on the existing bands, you can get up to 9.6 gigabit per second in the biggest channel. I don't know many users who need more than that. Certainly in Huawei, and we sell Wi-Fi equipment as well as selling mobile equipment, and they can potentially compete for spectrum. Our Wi-Fi people say we don't need any more speeds than 9.6 gigabits per second per access point. I don't know. We have no idea what technology would need that. Bear in mind, if you need another access point, just put another access point on fiber on, 50 meters further away. So we don't think there's any need for more spectrum for Wi-Fi. I don't know what IoT device would need more than that. I guess the biggest user of IoT bandwidth is video. I guess in theory, maybe VR or something, but you're still never going to get more than, 200 megabits per second or something, I would have thought. So we don't think there's any more need for more spectrum, and Wi-Fi 6E is a bit not that necessary to have more spectrum. We think the spectrum is more useful in mobile, because in mobile you're going to be covering thousands of people in, say, 3 or 5 kilometers worth of range, where you could potentially need to use up many, many gigabits per second per base station, whereas Wi-Fi only goes 50 meters, so you would never be needing that much speed. This is a very long answer. I also want to touch very briefly on something I forgot to mention earlier, maybe relevant for this audience. Actually, the biggest use case we've seen of enterprise 5G, we didn't quite expect it. It wasn't like ports or mines. It was called basically mobile private network. So using network slicing. I don't think Safaricom have yet really focused on that yet. I'm sure Gigi's been thinking about it, he can comment, but network slicing is probably the biggest potential beneficiary for all of you in this room, where you get your private network and they'll give you a guaranteed speed, a guaranteed latency, and a guaranteed SLA. On the no matter where, obviously there has to be a 5G network signal, but no matter where you are in the country, no matter where your staff is or your customer or your branch, you can do that. And you can't do that with 4G, as you can't really do it with Wi-Fi either. But with 5G, that's why we've seen really, really big growth, especially in Europe and in Asia, around having mobile private networks for enterprises. And I think that's been a bit unexpected, but it's seen really, really important. Businesses really want to invest in that.
Awesome. Unfortunately, we've run out of time, but you can talk about it very quickly as you make your closing remarks. Very quickly.
Okay, on the network slicing, it's a very interesting. It's whereby you're given some part of the spectrum, and then you give
that business, network. That network slicing business comes to me. Okay.
Yeah, we'll cut a deal. Yeah. So in short, without taking a lot of time, is you get part of the spectrum, and then it's allocated to you. So we are doing some pilot with Huawei, and we have a few organizations on board, and looking forward to make it a success, because it's really something very interesting. Good.
Parting shot?
Parting shot, technology is developing. We are seeing convergence of telecom with IT, with 5G. It is really converging. It's the first convergence we are seeing with telecom and IT. So 5G being an enabler, we are looking at more machine-to-machine learning, more AI, and a lot of machine convergence. So 5G being a good technology and a great enabler, good and exciting times are ahead for technology. Thank you.
Awesome. Ben?
I look, networks innovate to get ahead of competition, right? So people are, particularly in South Africa, which is very competitive, as Adam said, we're seeing all the networks, rolling out 5G to stay ahead of each other. And I do think that, across Africa, it would be nice to see in some countries, places where there isn't enough competition, it would be nice to see emerging networks come and governments to enable 5G spectrum to non-incumbents to enable competition. Because what really sparked off this whole mobile revolution was, the introduction of competition into the market.
Correct.
And we're seeing in some countries stagnation of competition. And it would be nice if 5G is a springboard to actually introduce some.
Oh.
Thanks. I just 2.5 quick points. The first one is I fully agree with Gigi about the importance of AI and machine learning. I think 5G itself, its fast internet stuff is not really that useful from a business case unless you've got the applications running off it. If you look at like the quality control using high quality video in manufacturing or inspection of power lines and stuff, a lot of it is going to be video, a lot of it can be done by AI and cloud, and that's really, really critical. And it's great to see so much progress in Kenya the last 3 years around that. The second point was this, the biggest challenge around 5G rollout, I think, is, as it has been actually for infrastructure providers for several years, how does the telco make money out of it? And actually the biggest revenue generators we've seen, like in China, 10 times more of the benefits that an end user pays for the benefit of 5G goes to like the service provider, as in like the software or the AI or the cloud or the integrating partner that's layering something onto the network itself. So actually, for most people here, that's probably the really big opportunity. All the stuff we've been talking about, the enterprise use cases, they all require customized hardware, or it will require certain platform, software, cloud, and other things like that. And then the half a point is now actually we're talking about 5.5G in Europe and Asia especially. It's actually coming only a year and a half away from now before it gets rolled out and approved by the standards bodies. And then we'll be looking at 6G, which is at the end of this decade. But one of the really interesting things, if you want to look into it more, is around the issue of sensing. So in the future, telecoms networks will be doing more things like LiDAR and radar, and looking at sensing and millimeter accuracy positioning based on how the radio waves are hitting something and bouncing back, and triangulation and so on. And that's really, really interesting. So it's kind of mind-boggling when you start thinking about this, but there's been lots of white papers around 6G, 5.5G. If you're interested in that stuff, go check it out. And then we can move past 5G onto 5.5G.
Thank you so much. And that's the year ahead, guys.